Problem number 63. A meter stick is held vertically with one end on the floor. So you can see the diagram. We had a meter stick which is kept exactly vertical to the surface of the floor. Consider the floor surface is horizontal. We kept the meter scale vertically. So one end of the meter scale is exactly kept on the surface of the floor and then is allowed to fall. So we just leave another end to fall to make the stick to fall on the floor. So what we have to do, we have to find the speed of the other end just before it hits the floor. So when you allow this meter stick to fall, it will follow this dotted line. Am I right? So when you just see this diagram, when you leave this another end, what will happen? The meter stick is about to fall on the floor. So now when it is about to fall, we have to find what is the speed of the stick when it is about to hit the floor. And you have to see the hint. Consider the stick to be thin rod. Why they mention thin rod? Because we have to use the formula for moment of inertia for the thin rod. So you have to consider this is not a meter stick. You have to consider this stick as a thin rod. And then we have to use, for finding the speed, we have to use the conservation of energy principle. So let's rewrite the information clearly. You can see this rod. The midpoint of the rod is exactly at the middle. That means it's exactly the height, because generally when you measure the height, we have to consider the midpoint. So that means here the height based on the midpoint of this meter stick, which is nothing but L over 2. That means the total length from here to the edge, which is nothing but L is equal to 1 meter. Clear? Now what we have to do, we have to use the conservation of energy principle by law of conservation of energy, law of conservation of energy, potential energy, which is equal to kinetic energy. But the most important thing, we have to consider the kinetic energy for the rotation, because the rod is about to rotate about this axis of rotation. So we know the formula for potential energy, which is nothing but mgh, and the kinetic energy rotation is nothing but half I omega square. Clear? And the most important thing here, the value of I, because they clearly mention consider the stick to be thin rod. So the moment of inertia for the thin rod based on this is our axis of rotation. So here the axis of rotation is at edge of the rod. So for the edge of the rod axis of rotation, we have to use the formula, which is nothing but ml square over 3. What's the value? ml square over 3. So I have to take this I have to substitute here. So if you substitute, what you will get? Half ml square over 3, and then omega square, because the omega is not given, so we can use the relation between the linear and the angular speed, v, which is equal to r. This is v. Okay, so v, which is equal to r omega. Here r is nothing but the length, so we can write this rule as v is equal to L omega. Therefore omega, which is equal to v over L. So in place of omega, I have to substitute v over L. So here v square over L square. So left hand side we have mgh. Clear? Now the height is nothing but L over 2. Clear? Because as I told you, when you measure the height of the rod based on the center of mass, it is nothing but the half of the total, right? So we have to substitute mg in place of h. I have to use L over 2, which is equal to ml square v square over 6L square. So now we can cancel some term. So L square get cancelled with this L, mass get both side, we can cancel the mass, right? So what is remaining, we have, and also we can cancel 2, this will be 3. So what is remaining? GL, which is equal to v square over 3. So therefore v square, which is equal to 3g multiplied by L, correct? So now I have to take the square root on both sides. Therefore v, which is equal to square root of 3 multiplied by g multiplied by L. So 3 multiplied g value is 9.8. The total length of the rod, which is nothing but 1 meter, right? So we have to substitute 1 here. So here I got the answer as V, which is equal to 5.42 meter per second. So this is the answer for this question. That's it. Thank you.